In this episode, we take the guardrail idea and focus it on one of the most common ways AI systems get steered into unsafe territory, the prompt itself. A prompt firewall is not a literal wall made of bricks, and it is not a single keyword filter that can be bypassed with clever spelling. It is a defensive layer that treats prompts and surrounding context as untrusted input and then applies multiple checks before the model ever sees the request in its final form. The reason this matters is that LLM systems are unusually sensitive to instruction content, and attackers know that if they can smuggle instructions into the model's context, they can sometimes bend behavior. A prompt firewall tries to reduce that risk by filtering obvious abuse, classifying intent, and checking boundaries between instructions and data. For beginners, the simplest way to think about it is that the prompt firewall is the bouncer at the door. It looks at what is trying to enter, asks whether it belongs, and decides whether to let it in, modify it, or block it. When you build this layer thoughtfully, you reduce prompt injection success, reduce data leakage, and improve consistency of refusals under pressure. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Filtering is the first concept in the title, and it is the most familiar, but it needs a more mature interpretation than the word sometimes suggests. Filtering is the act of inspecting input and deciding whether to allow it, block it, or route it to a safer path. A basic filter might block certain obvious harmful requests, like direct instructions for wrongdoing, but a prompt firewall goes beyond that by looking for patterns of manipulation and boundary crossing. For example, attackers often use phrases that attempt to override rules, request hidden instructions, or demand access to restricted data. They may also use long, complex prompts that try to confuse the model into ignoring constraints. A prompt firewall can filter for these patterns and either block them or trigger stronger controls. Filtering is not only about censorship. It is about reducing dangerous interactions that the model is not reliable at handling safely on its own. The key beginner lesson is that filters are not meant to replace the model's safety behavior, but to reduce the number of risky cases that reach the model in the first place. Classification is the second concept, and it is about understanding what kind of request is being made so you can apply the right policy. A request to summarize a paragraph has a different risk profile than a request to generate a persuasive message, and both are different from a request that touches personal data or security-sensitive operations. Classification can be as simple as assigning a request to a category, such as general help, sensitive data handling, security troubleshooting, or policy-related content. Once the prompt is classified, your system can choose which model to use, which guardrails to apply, and whether human review is needed. This is one reason classification is powerful. It allows you to tailor controls to context instead of using one harsh rule for everything. Beginners sometimes think classification is only for analytics, but in security it is a control because it determines the treatment of the request. If you misclassify, you might apply weak controls to a high-risk request or strong controls to a low-risk request, both of which create problems. Good classification is therefore a foundation for both safety and usability. Instruction boundary checks are the third concept, and they address one of the trickiest aspects of LLM security, separating what the system should do from what the system is analyzing. In many real applications, the prompt is not just the user's question. It also includes system rules, tool descriptions, retrieved documents, chat history, and sometimes snippets from external sources. Instruction boundary checks aim to ensure that only authorized instruction channels can influence behavior. For example, if the system includes an internal rule like do not reveal secrets, that rule should not be overridden by a sentence hidden inside a retrieved document. Similarly, if the user pastes content from an email, the system should treat that content as data, not as instruction, even if the email contains phrases like ignore previous rules. Boundary checks are about preventing role confusion. They make sure the model does not treat untrusted text as if it has higher authority than it should. For beginners, it helps to think of this as enforcing a chain of command. System rules outrank user requests, and user requests outrank untrusted data. Boundary checks enforce that hierarchy. To understand why prompt firewalls are needed, it helps to look at how a typical LLM request is assembled. The user provides a prompt, but the application often adds additional context, such as a system message that defines behavior or a block of retrieved content meant to help answer the question. This combined prompt becomes the model's working environment. The attacker's strategy is often to influence that environment by inserting instructions into places that were meant to be data. If they succeed, the model may follow those instructions and break your intended policy. A prompt firewall tries to catch these attempts before they reach the model by scanning for injection-like patterns and by restructuring the prompt so that untrusted content is clearly marked as untrusted. It can also limit the amount of untrusted content included, because longer context increases the chance of confusion and makes it harder to detect malicious instructions. The key is that a prompt firewall is about controlling how the model is conditioned, because conditioning drives behavior. A mature prompt firewall does not rely on a single technique, because attackers adapt. It combines multiple checks that each catch different kinds of abuse. Filtering might catch direct harmful requests, while classification might detect that the request is about a high-risk domain and should be handled with stricter policies. Boundary checks might detect attempts to override instructions or to request system prompts. You can also include checks for sensitive data patterns, like secrets or personal identifiers, and then route those prompts to redaction or to a refusal path. Another helpful control is normalization, which means rewriting the prompt into a safer internal format. For example, you might strip out obvious manipulation phrases, or you might wrap untrusted content in a way that reduces its chance of being interpreted as instruction. The important beginner lesson is that you are not trusting the raw prompt. You are transforming it into something the system can handle safely, while preserving the legitimate user intent. One common beginner misunderstanding is thinking that prompt firewalls are purely about blocking bad actors. In reality, they also protect against accidental risk created by normal users. A user might paste a long log that includes credentials, or a user might paste a contract that includes private information, or a user might ask for help in a way that unintentionally triggers disallowed content. A prompt firewall can detect these patterns and prevent accidental leaks by warning, redacting, or refusing. This is important because most real-world risk is not a movie villain. It is ordinary behavior intersecting with powerful systems and messy workflows. Prompt firewalls can also make systems more consistent because they reduce the variability of what the model sees. When the model sees cleaner, more structured prompts, it is more likely to respond predictably. Predictability is a security feature because it makes it easier to build reliable controls and to test them. Overreach is the risk on the other side, and a prompt firewall that blocks too much can push users into unsafe workarounds. If your filter is too aggressive, users will start rephrasing endlessly, or they will use unofficial tools that have no oversight, or they will stop using the secure system altogether. That is why classification and policy alignment matter. Instead of blocking everything that looks vaguely risky, you apply proportionate controls based on context. A user asking about high-level defensive concepts should not be blocked just because the topic is security. A user asking for step-by-step wrongdoing guidance should be refused. A user pasting private data should be redirected to a safe workflow that protects that data. Building a prompt firewall is therefore a balancing act. It must be strong enough to reduce abuse, but precise enough to support legitimate use. Precision comes from understanding your use cases and from measuring false positives and false negatives over time. Prompt firewalls also benefit from clear, consistent responses when they do intervene. If the firewall blocks a prompt, the user should understand what happened in a calm, non-argumentative way, without being given a map for bypassing the control. If the firewall redacts sensitive elements, the user should be told that sensitive information was removed so they can decide whether to proceed. If the firewall classifies a request as high risk and routes it to a stricter path, the experience should still feel coherent rather than random. This matters because user trust affects security outcomes. When users feel the system is unpredictable or unfair, they experiment more aggressively, and that experimentation can look like probing. When users understand the rules, they are more likely to work within them. A prompt firewall is therefore part of both security and user experience. It is not a separate add-on. It is part of how the system communicates boundaries. Finally, a prompt firewall is only as strong as its placement and its maintenance. It needs to sit in the request path before the model is called, and it needs to be enforced consistently across all interfaces, such as web applications, mobile apps, and internal tools. If one interface bypasses the firewall, attackers will find it, and even accidental misuse will concentrate there. Maintenance matters because attackers and users adapt, and because model behavior can change after updates. A good program measures how often the firewall triggers, what kinds of prompts are being blocked or rerouted, and whether unsafe outputs are still slipping through. It also revisits classification rules as use cases evolve. The biggest beginner takeaway is that prompt firewalls are not about winning a single battle. They are about building a stable, enforceable boundary between untrusted user input and the powerful generative system behind it. When filtering, classification, and instruction boundary checks work together, the model operates inside safer lanes, and your overall system becomes harder to abuse, easier to monitor, and more resilient as it grows.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.